Hey everybody. Um, Usually a bit of warning here. Done a lot of conferences and with previous Caroline Chappelle from Light Reading, and she usually presents me as the old grumpy guy. So a bit of warning there. To start with, I think we should look at service assurance, how it works, and not how we as vendor pitches how it works, but talking to our operations teams. I think we listen too much to product pitches rather than walking downstairs talking to the operations, or maybe we should ask our customers and users. And when it comes to network service assurance, I'm afraid that this is the truth of today. Users and customers are complaining about the network, but the operations team says everything works fine. You can look at a slide like this, but you can also look at studies. There is a study that actually says that 70% of the issues you are working with are reported by customers and users and not by your fault management system. So 70% of your job is done by your customers, which is kind of staggering. And I guess you've spent more than $10 on an assurance system, maybe 20 even. And so we're not proud where we are today, I would say. So why is it so then? Before I was at TailF and Cisco for a while, but before that I did spend like 10 years with assurance systems with on the leading OSS vendors. And I have to say, over those 10 years, I was never proud of the alarm list I gave to the operations team compared to what the real issues are out there in the network. How can that be? I think I'm simplifying, yeah, of course I'm simplifying, but I think one of the biggest problems is this, that you have your customer care issues. Customers calling in are angry, but the problem is there is no corresponding stuff in your alarm list. So the operations team are clueless. That's one part of the problem. Another part of the problem is that you have priority 1 alarms in the alarm list that doesn't impact the customer. So that means your operations team, they don't understand what's relevant for the customers, and they're working with unnecessary stuff. You can disagree, but in my experience of those 10 years with alarm lists, this is what an alarm list says. And you have probably spent quite a lot on the assurance system you have, but still this is the situation. Okay, so try to explain that our assurance systems doesn't really help us on focusing on the right things. They don't guide us where we should fix problems, and we actually have our customers and users be the assurance systems. That's where we are. Not that fun, to be honest. But here comes AI, right? Just throw a bit of AI and things will work. We go to conferences, and we've seen over the years various hypes. 2 years ago, everyone would have talked about OpenFlow and OpenFlow controllers, how that will simplify everything. And now we're talking about AI and machine learning. It's a magic wand. It will fix the issues for assurance. I started thinking, so when I talk to people in conferences and colleagues, I typically see two kinds of people. I see the believers. They read blogs, they check some posts on LinkedIn, and they have dinners with vendors. And then, yeah, this must be it. AI and machine learning will probably solve the problem. On the other hand, we have boring scientists. That picture is the scientific method. How do scientists work? Science starts with understanding what is the problem, what is the specific question I would like to have answered. And then they read books. They read 500 pages paperbacks. Amazing. Isn't it enough with a blog post? No, they read books. They go deep, they read, they understand, and then they test. They would never claim anything without running a test in the lab, doing mathematical proofs, and then writing a paper. Then they can say, my algorithm works. That's science. And you have these within your organization. The problem is that the scientists are probably at home because they're trying to understand the problem in the operations team, while the believers are probably here drinking wine. So that was a leading question. How many believers do we have in the room? Come on, how many believers? Be fair, how many believers? No, 2. I think it's at least 50% believers in the room. Yeah. How many scientists? Yeah, exactly. And I honestly think that we need to be more of scientists in the industry. We as vendors need to be more scientists. If you're a service provider, you need to be a bit more scientist and not just believe overhyped marketing departments. And the believers have hijacked machine learning and AI. Machine learning and AI is hardcore science, but believers have hijacked it and gave it to marketing departments. Okay, what is AI? This is, if you read newspapers, this is the believer version. Just throw any data to a box that is magic. Ask any question and you get any kind of answer. That's what scientists call generic AI, and generic AI does not exist. This is a machine that you can say, unload my dishwasher. Please fix the problem in my network. Please change diaper on my kid. That's generic AI. We're not even close to generic AI. If you go downstairs to our booth as vendors, this is how we market AI as vendors, meaning throw traps, throw syslogs, throw whatever low-level device counters into a box we call AI, and then any OSS and BSS question can be answered about customer experience. That is generic AI, and generic AI does not exist. Maybe you believe that the Terminator movie is true, then you believe this one, but this is how we market products today. What does exist and what works extremely well, and we had lots of good examples from the previous speaker, specific AI. That is science that works, meaning you have a specific question like predict the video playout time. I want to predict the video playout time. That's a specific question. Assuming I have relevant data, which you gave examples of, I have probes that can measure KPIs related to video. Then I can apply a bit, and now, isn't this sad? It's mathematics. Then I can apply mathematics to that relevant high-level data, to that specific question, in order to get a specific answer. And previous speaker Rami had lots of good examples of specific AI. Question per question, make sure you have relevant data, and I need to read some mathematic books, because there is no AI machine. You need to pick algorithm. AI is mathematics. Most AI projects today are statistics, but that's not marketing. I mean, if you do, it's more fun to say AI than statistics. So, hear me now, this works. This works perfectly fine, but generic AI does not exist. You can't operate your network by just throwing low-level data into a magic box. What about this boring mathematics then? I won't go into details here, but just so that we can become a little bit more of scientists, all of us. That machine learning, that AI box, there's no generic such thing. You need data scientists. So, as Rami said, if you collect the correct KPIs, you have a specific question, but you can't throw that to a magic box. Then you need to get the data scientists in that have read probably 20 books. Should I do linear regression? Should I do decision trees? Should I do Gaussian? No one will tell you. You have to be smart. You have to read your books. Then you can answer a specific question. The interesting thing right now on AI and machine learning is that you probably, when you did your university studies 20 years ago, you read statistics. And many of these algorithms, like linear regression, I would say, that is statistics, but most of the AI projects today are linear regression. Works fine, but it's still statistics. So if it's mathematics, it's no magic box. So next time a vendor like me tells you that you can buy my magic AI machine and run your network, you should ask a couple of questions. What's your algorithms? What's the required input data? What are the specific questions I can answer? That works. Here's an example we did at Netrounds together with a partner called Elasticity. So we did, first of all, measure by using active traffic. We measured RTP jitter in the core network. So relevant, high-quality data, RTP jitter. We gave that to a mathematics, the data scientist. He studied that. He defined a regression method, and thereafter we could predict 1 hour ahead of time the RTP jitter. One specific question, relevant high-level data, and a specific algorithm. So here you see sort of the prediction we did versus the real values. Works perfectly fine. That's specific AI. Relevant data, specific question. I'm afraid of that many people today are spending hundreds of thousands of millions of dollars on this. Don't do this at home. Don't try this at home. Many people are building big data lakes. They don't care about the data. They just, let's throw all the low-level noise we have from the devices. Maybe we should call it telemetry instead of traps, but just throw whatever we have into a big data lake and then try to answer questions like this. You try to answer very generic questions around customer experience, service quality, but you have low-level irrelevant data as input. This is waste of money. Totally waste of money. Don't try that at home. There's actually an interesting study. So if you think I'm rambling, this is a study. You can pick it up. Why do efforts fail in telecom? You have the URL to the study here. Lack of clear question to answer. 1 out of 3 projects are failing because they try generic AI. They don't start with a specific question. 30 plus and 50% relates to we don't have relevant input data. And match that to my picture here. You need relevant data, you need a specific question, you need to know your mathematics, then you can have a specific answer. And this is industry experience. It's a really interesting report to read. Okay, I will also turn a little bit back to the same topic as Rami had about this relevant input data. You had lots of good examples there. I sort of give a different perspective to the same topic. Let's say we have our mathematical function here, might be machine learning algorithm, might be regression, and we are feeding that here. Probably we have something we call big data, and we're collecting device-oriented. We're collecting traps, logs, counters from individual devices. Just what we have, just throw that into that big bucket. It might work if you have device-oriented questions. If you want to know what's the health of that specific device in an hour, will the CPU load on that specific device go higher? But remember, that works if you have device-oriented questions. So that's of course needed, but it won't help you predict customer experience. And this is again what I'm afraid too many people are trying, collecting device data and predicting customer and service quality. If you would like to answer questions that relates to service quality and customer experience, you need service-related KPIs, not device-related KPIs. So in those cases, you need traffic. And again, Rami had good examples there that you need data that relates to the network traffic, to the data plane, and not management plane from the devices. So, for example, at Netrounds, we have test agents, or we can call them probes, that are active. So these guys send data at the data plane acting like an end user. So you get synthetic traffic into the network like you were an end user, and you collect that and feed that as input to your mathematics. Then you can predict service quality, you can predict how happy customers are. That is impossible if you go with this architecture, which I'm afraid too many people are doing today. Collect whatever we have from the devices and try to answer customer-related questions. That's generic AI, won't work. So, summing up, what I would like you to do is be scientists. Go visit that department that is called operations. Talk to the super smart guys you have that actually runs your network and ask them, what are your top problems in the network? Spend a couple of days in the network operations center. What are the top 5 most fundamental questions we should work with? And make sure you have the relevant data to answer that. Make sure you have the right algorithms to answer that. And also think a little bit, where do I spend my license money, or where do I spend my internal resources in developing? I see a little bit too much experiments in big data technologies, collect whatever we have, build platforms. Let's see what kind of questions we would like to answer later. That's going to make you fail. So, be scientists, please. I have a little bit more serious version of this thing and explaining what's the difference between machine learning, deep learning, etc. If you go to the Netrounds booth, we have a paper called Small Data or Big Data, and you can see what I'm sort of proposing here. Use small data, things will be faster. Thank you.